So we have some workaround. Essentially, we want to filter out honeypots that have no activities. So anyway, so that's kind of limitation that I mean at this point doesn't cause a lot of problems, but it's not quite right. But anyway, the main the sort of the more interesting problem here is that, so we say that you deploy honeypots, right, and then you observe the activities, and then you say, okay, if the same patterns happen, then you know there's a worm. Now the question is, how do you know how many observations do you need? Okay, so that's a question that we think is important, because at the end we want to reduce the false positive. But think about in this particular problem, for honeypot to actually be for a false alarm to actually show up, the same pattern, same false pattern should have to be consistently show up across multiple honeypots, and that's very unlikely. Suppose you say that you see outgoing traffic, and you say, okay, it's triggered by this incoming activity at port C. Suppose this is a false positive, but if you see the same false positive across multiple honeypots, that itself is very strange. It's very unlikely that it's a real false positive. Okay, but again, how do you find the sample size? There's some work in statistics which is not how to put it. They don't have any principal way of telling you what is the correct sample size, and they only have rule of thumb. So rule of thumb is so-called rule of 10. Okay, I'm going to actually skip a little bit details because of time. So the reason that we want to deal with sample size also is that we want to make sure that you have high enough confidence that you can reject a null hypothesis. Meaning when you say this particular event X1, right? Meaning port activity at port 1 contributed to outgoing traffic. It's actually valid, right? So that's the beta 1 value that we'll compute. So the probably want to skip that. Okay, so the rule of 10 essentially says that suppose you have a lot of observations, right? And these are rare activities. Suppose you want to explain those rare activities. So this rule of thumb meaning that you want to have, for each parameter, you want to have at least 10 observations for the least frequent value. So this would be too abstract, but let's use an example here, right? Suppose I have 50 observations of acquired honeypots, meaning y equal to 0, meaning that the honeypot doesn't send out any traffic. Okay, and then there are 30 30 observations, 30 active observation, meaning there are 30 observations where the honeypot sends out traffic, and then essentially the model should have at least 3 parameters. So you cannot have more than 3 parameters, meaning port activities. Suppose you only have 3 ports that contribute to the outgoing traffic, then there's a chance that you can explain. Okay, yeah, but otherwise, if you have a traffic to many ports, then you can explain which port actually contribute to the outgoing traffic. That's the intuition. All right. So the testing, we did it very well. Again, only limited testing had no positive. So really work. CMU doing something similar, but they're not doing any logic analysis. But the idea is very similar. Okay, analyzing activities across multiple file systems. Anyway, to conclude, I think we need to consider architecture of the anomaly idea so that the Bayesian detection rate is high enough, so that so the point is that then you have small enough rate of false positive, and then the two architecture will be cascade or correlation. Okay. All right. Thank you.
I don't think we have time for questions. Let's thank the speaker.
Walking back to